come and take a sneak preview at our course on Statistical Data Analytics. The focus of the course is on regression analysis. Do you remember regression from your days at college or university? Yes? And I heard you groan. Yeah, that's right. You remember it. It's the stuff you learned for the exam and then you promptly forgot so that you could make room in your brain for other important things. And I don't blame you for forgetting it because you were never shown how it applies to the real world. But now you're in luck because regression is based upon logical and plausible relationships. And guess what? Business data is full of logical and plausible relationships. So let us show you how this powerful analytical tool can be applied to the business world, your world. Here are just a few examples of relationships in your business data. Don't the bad and doubtful debts you incur depend on the credit you extend? The operational costs a branch incurs should relate to its output and activity. Freight costs depend on the weight and distance of items shipped. If you happen to be generating revenue from bridge tolls, doesn't your revenue relate to the volume of traffic? If you've ever paid property tax, you know it's a function of the cost of the property sold. The size of your business premises affects your electricity use. The number of defective items manufactured relates to the manufacturing process. Usage of an asset impacts upon its maintenance costs. Truthfully, we could go on and on with these examples. Would you like to be able to predict and audit and monitor such relationships in your own business data with 95% confidence? I can. Plus, I can find outliers, both best and worst practice. And by the way, the IIA says that random sampling misses 90% of the outliers. I can find them and reduce my audit scope, all because I know how to apply regression. Allow me to demonstrate. You're auditing the reasonableness of maintenance costs of very large water pumps. Why are you interested in water pumps? Well, you work for a global construction firm, and your firm builds high-rises all over the world. Lucky you. The buildings need massive air conditioning systems, supercooled by large water-injecting pumps. The pumps alone are worth millions of dollars, and your firm spends a lot on maintenance of them, something like $65 million a year. Not to mention that there's 4,100 of these pumps scattered across the globe. Imagine the business risk if one of these air conditioning units stopped. So your problem is how to audit them. And here we're talking loads of travel, which sounds like fun until you've lived out of your suitcase for 365 days of the year and forgotten what your family looked like. So, what to do? Let's see how to perform regression and what impact it can have on our audit approach. You've started with a sample of 17 pumps randomly selected. So you're expecting a plausible relationship. The more work a pump does, the more maintenance it will need. And to begin with, we're going to chart the data, determine the R-squared and the regression equation. Always chart your data first so you can see any patterns, you can visualize the data, and let the data talk to you. Let's do this together because our courses are hands-on. There'll be no snoozing in our courses. This ain't no lullaby. And you might be pleasantly surprised, it's easier than you think. Using the Excel maintenance file, this demonstration is recorded in Excel 2010. Excel assumes you've built your data with your X column on the left and Y column on the right, and your columns must be next to each other with no gaps. Now highlight the data from which the chart is going to be created. It's not necessary to highlight the column headings. Now click on the Insert tab up in the ribbon and then select Scatter under the chart grouping. Under the types of scatter charts, Select the upper left Scatter with only markers. Now you have a chart in your worksheet, and this is the starting point for running regression. To help you replicate these procedures and get them into your muscle memory, we've provided all the keystrokes and screenshots for you. We have some user-friendly functionality built into our e-learning platform. For example, if you sample our free trial, the tutorial will pause here until you click the Next button at the bottom right of the screen. This is to allow you to try these steps by yourself. There'll also be the option to click on a button below called Previous if you want to watch how to do this again. And perhaps you could even minimize this screen, make it half the size of your screen, and put Excel on the other half, and click along with us. Use the seek bar at the bottom to pause along the way. For those who might prefer a hard copy to follow along with, there will be a link to other resources, and you can print the screenshots. In our full course, we'll be making all of these options available to you every time we demonstrate what to do with the mouse on screen. So, you have the option of choosing the method that suits you best, and you can work at your own pace. Now that you have a chart in your Excel document, make sure you're in chart mode. You'll know that you are by making sure there's a thicker grey border around your chart. When you're in chart mode, right-click on one of the blue data points in the chart and then select Add Trendline from the pop-up menu. In the Format Trendline dialog box that appears, we want to choose Linear. It should default to that. And in the bottom of that box, we need to select Display Equation on Chart and Display R-squared value on chart. Once you've done that, click Close. You now have the regression line, the R-squared, and the regression equation displayed on your chart. To move the equation and R-squared so that it can be read, click and drag it all in one motion up to the right-hand corner. Congratulations! You've just run regression via the trend line in Excel. And you've just confirmed your plausible relationship. Across the x-axis, we see that when more water is pumped, then across the y-axis, we see more maintenance is needed. And why do we care about those equations? Well, a good R-squared shows the strength of your data's relationship. We'll explain what a good R-squared is in the course materials. And the equation there, the y equals, that's the equation for the line, the regression line. Do you remember that old equation for a line? Y equals mx plus b. Another thing you learned for the exams at university or college and then forgot? Well, what you've got there is y equals the gradient of the line and its y-intercept. But before your eyes glaze over, let's tie the maths to the business data. Because applying it to the real world, in a business sense, what we are looking at is y equals our variable costs plus our fixed costs. So then applying it to this specific example, we have a fixed maintenance cost for our assets. That's the 43.082 you see there. And then we also have a variable cost that depends on the asset usage. Or to put that another way, depends on our X variable. That wasn't so hard, was it? You've just done what Dr. Dan calls aftermath, using math after college to solve business problems and using it to improve the efficiency and effectiveness of your audit process and potentially your business processes. Now, linking back to how regression can help you to audit smarter, if you were to audit this data in the traditional way, perhaps if you tried to test this sample of 17, or even just visit the 4 largest pumps here, you're going to be doing a lot of travel. The 4 largest maintenance costs are scattered across Pakistan, India, China, and Russia. But what if you could predict such relationships with 95% confidence and target your auditing to only those pumps that are out of control? Let's find out where that outlier is. If we hover over the data point, we can see that it corresponds to X of 28,700 and Y of 167. So when we look at our columns of data, we see that that corresponds to London. Now here's something I prepared earlier. Our course will teach you how to build these prediction intervals, those red parallel lines, so that you can, with 95% confidence, identify which items are outliers and target your auditing to those. So what we're doing here is that we're statistically predicting what the figure should be at a percentage of confidence given peer data. Once we do this, we can see the outlier clearly, not judgmentally, but scientifically. With those red bounds, we're now 95% confident that London is an outlier. When was the last time you had a chart like this on page 1 of your audit report? Wouldn't that be easier than writing a 1,000-page report? Dr. Dan's philosophy is, let the data do the talking. If you can do analysis like this in year 1 of your audit, then you've just laid the foundation for auditing smarter. Because then you can test your initial sample of 17 for representativeness and validate your model. And by the way, we can give you a neat work paper to help you test your sample for representativeness. Once you've validated the model, then you're ready to reap the benefits of applying regression to your business data. Because then you can run your whole population through the model. And that could be a population of thousands of transactions. So what's the benefit to you of validating the model and then putting all your transactions through it? Well, then you can audit by exception, because all of your outliers will sit neatly outside those red bounds, and then you can target your audit testing. By that I mean the outliers have just selected themselves for your sample, and you can be 95% confident in the results. Now let's just stop and consider the impact of what I just said. You could target your auditing. Think about it. If 5% of your pumps are bad, or if fraud exists, with a population of 4,100, then 21 of your pumps are bad. In a judgment sample, what's the odds you pick any of those 21? Remember, IIA research shows that random sampling misses the target 90% of the time. But using Dr. Dan's advanced maths, we could find all the questionable pumps. Now we're really talking when it comes to efficient auditing. And seriously, when was the last time you wrote an audit conclusion saying you're 95% confident in your results? But it gets better. You can get even more efficiencies out of this approach because you can take it further. You can build a model just like the one in this demonstration. You can run your data, refresh this monthly, and then you're building a proof of concept for a continuous monitor. Do you realize what this means? Do you realize what's in it for you? We can teach you how to build a model that you update regularly with the press of a button. We'll show you how to do this in Visual Basic, and by which you audit thousands of transactions by exception with 95% confidence. Isn't that simply the ultimate in efficient auditing? What we've just shown you and talked about is a simple demonstration of simple linear regression, 1x, 1y. Anyone can do this. But Dr. Dan knows that not all data is linear. Let us show you how to take this further. We can offer you more than 25 years of experience that Dr. Dan has of applying maths to business. Let us help you flex your maths muscles. Stretch out and try some curvilinear regression, some polynomials, some multivariate regression. When was the last time you used the word polynomial, let alone ran the math? While we're on it, have you heard of seasonality in the data? Well, that's polynomial. Let's dust the cobwebs off all that old stuff and work smarter, not harder. And check this out. We've even got software that does the heavy lifting for you at the click of a button. All you need is some of your own business data and some plausible relationships to model. Thank you for viewing this short demonstration of our e-learning format.